Okay, guys, let's start up with factoring completely. This is a step-by-step guide. And start at the top, go to the bottom, and you have done everything you need to check. So, first off, it says, is the problem in the correct order? Highest power to lowest power. All right, gonna tell you. This is not going to happen in this lesson. I already put everything from highest power to lowest power, but it is the first thing we check. But I already did this for every problem since we're just starting. Is the highest powered term negative? Well, if the answer is yes, then it counts as a GCF. So if the highest powered thing is negative, then you think of it as a GCF, meaning you're going to take it out of the problem. Are there any other GCFs? If there are, you're going to take them out also, okay? And if there are any squared terms remaining, you keep factoring. It means you have not factored completely. So let's go through some examples. You're going to see a couple different looks, but they all obey this exact same order of stuff. Like I said, the first one here, I already did for you. So let's begin. So I have four examples here that are all very similar, because what's going to happen is, once I take out the GCF, I'm going to be finished. That's what makes these all the same. See, a greatest common factor is something that they both have in common. And in this one, this guy has an x to the fourth. This guy has an x to the third. And believe it or not, the greatest common factor is always made up of the tiny guy. So this guy right here, this guy right here, x to the third, is of those two guys, because one's x4, one's x third, x to the third is the greatest thing they have in common. So I would take the x third out, and it's basically I'm doing multiplication in reverse. I would say, you know what? This times this would give me x to the fourth, plus I would need a 2 right here. And if I were to multiply that out, I would get back the original. So here's the thing. It was already in the right order. Fourth power is bigger than third power. The highest powered thing right here is x to the fourth, and there's no negative here. If there was, I would say it's net, but there wasn't. So I look and I say they do have a common factor, and that common factor was x to the third. I take it out front. Now take a look at what's left over is x plus 2. There's no squared here. There's no third power here. There's nothing crazy like that. It's a first power. If we wanted to, we could write a 1 in every single time we factor something out of a binomial like that. We could do that if we wanted, but nobody does that. Nobody writes it in. But the thing is, since there's no squared left in, like I'm not squared, there's nothing left over that's squared, I'm done factoring. If there's any squared terms remaining, then we keep factoring. But on this one, we're done. So guess what? I'm going to erase these arrows here. That is our final answer. So right here, take a look at it. This guy is fifth power, this guy's fourth power. The greatest common thing they have in there is x to the fourth. But wait, there's more. This time, there's numbers. And we did this in a previous set of problems, but we didn't have any huge powers. So that's what makes this a little different. We're going to take out the 2 and the x fourth. Why? Because it's the greatest thing that they both have in common. Now, once again, I'm pretending that I'd have to multiply back to get back what I started with. So 2x to the fourth times x would give me x to the fifth minus, because I have a negative here, 5. Why? Because 2 times 5 is going to give me back 10, and there's my x to the fourth that I had here. So I'm going to erase those arrows again, and I'm going to say, hey, that is all I can do, because nothing left over here is squared. That's not a squared, that's not a squared. We don't ever write those in because it looks weird, but if there's squared stuff remaining, I keep factoring. Otherwise, I'm done. So today, this lesson is all about just factoring until you can't factor anymore. Now, here's the first time this has happened. We have fourth power and third power. Who's higher powered? The fourth power, and he's negative. So this time, when I take out my GCF, I'm also going to include that minus sign. Why? You're going to find out in the next video. I'm just telling you, if the highest powered thing is negative, let me scroll up a little bit. If the highest powered thing is negative, we take it out like it's a GCF. So I'm going to take out the negative, but I'm also going to take out the x cubed. Let's work it backwards. Let's build it back. Negative x cubed times x, that would give me negative x to the fourth. But I'm going to put a minus here and put a 2 this time because I already have the negative out front. A negative times a negative 2 would give me back that plus that I need. And there's my x third. I already have it taken care of. And once again, I'm going to erase those arrows out of my way. And I'm going to say, guess what? That is the answer. Like I said, every single one of these first examples have something in common. That something is once I take out a GCF, that's it sometimes. Like I said, this isn't squared. This isn't squared. I could write ones in there. I'm not gonna get rid of them. I only keep factoring if there's squared information remaining, and I don't see any. So let's say, what do you think I'm going to take out of this one? Is the highest powered thing negative? Who's higher powered? This guy is the higher powered thing, so I'm going to take out that negative. But I also see they have a 3. 3 goes into itself and 3 goes into 9. And then I'm going to say, hey, I could take out that squared, and then I'm going to build it backwards. This time I'm going to do it a little quicker. Negative x squared times x would give me negative x cubed. And I already have a minus, so I need a plus, because a negative times a positive would give me back that minus. And all I need here now is a placeholder. That would be a 3. And I am done. So if you need to, pause it, take a look at these. Find that pattern that I'm showing you, because it doesn't change. Once you know that trick's going to stay the same. But what makes all of these problems the same? Once you take out the GCF, you're done. Sometimes that happens. Well, let's look at these, because these ones are not like that. These ones have a special trick in it called the difference of squares. These ones all have the exact same thing. I hear my kids spazzing out. The difference of squares. Let me show you what that means. Hey, first things first. That guy's the highest powered thing. He's not negative. This guy's only x to the first. They didn't write it in, but I see it and I go, hey, x is the only thing I can take out. But once I do that, that's what's left over. But here's my trick. Here's my thing. If there's squared information remaining, I'm not done. If there's squared information remaining, I got to break it up. And I don't know if you guys remember this from Algebra 1, but that's why it's in this video. This can break up to look like this. I'm just going to show you and then we'll talk about it. That's the final answer for question 1, or for this example. This right here is called the difference of squares. In mathematics, they say difference for the word subtract. Like, what is the difference between 11 and 4? The difference between 11 and 4 is 7. Difference means minus. So whenever you see a difference, that's the same as, minus sign, it's the same as difference. And then, what times itself would give you x squared? Well, that's x. What times itself would give you 16? Well, that's 4. And the pattern for difference of squares, because that's all it is a pattern, says you do x plus 4, x minus 4. Let's do it again. What do they have in common? What's the GCF? X cubed. And if I take out x cubed, I get x squared minus 49. I surely do, but once again, I'm just going to remind you, when you take out that GCF, what did I say? If there's squared terms remaining, you keep going. So on this one, do you see what I mean again? The difference of two squares. What times itself is x squared? Well, that's x. What times itself is 49? Well, that's 7. So this problem breaks down. I leave the x cubed out front, and then I take this and I just do this little trick. X plus 7, x minus 7. And there's my answer. So, the first set of problems we did, once you took out the GCF, there was no squared information left, so you could stop. Here, you take out the GCF, you see there's squared information, you keep going. So, is the highest powered thing negative in this example? I would say it is. I would also say I could take out an x because that's the greatest thing they have in common. But don't forget, you take out the negative with the x. So let's build it backwards. Negative x times x squared. That's how you get negative x cubed. But negative x times, well, it'd have to be another negative, right? Negative times a negative would give you the positive. And the x is already there, so you just need a 4 to hold the place. And then I'm hoping you see it and you go, oh, this would be x plus 2, x minus 2. Now, when I make up practice problems for you guys, I try to take a little bit of each thing I have to cover and put it in the assignment. So you're going to run into this. How are you going to know that you're doing this trick? Once you take out the GCF, if you see squared information, you still have factoring to do. Okay, but like I promised, every problem, I wrote every single problem. So the highest powered thing goes first, then it goes smaller powers down the line. We're not going to mess with anything yet that's different than that. So let's see. What makes these ones different? Let's see. Hey, I didn't put any numbers in the front on these ones right here. No, I did not. There's no numbers in the front. So I stuck a couple numbers. And I've made up two problems that look almost the same. The reason I wanted to do that is one of them has the difference of squares in it. The other one does not. So I wanted to make sure you recognized which one is which. So in the top one, they both can be divided by 3. 3 does go into 75, right? 25 times. I could take out this x, so I'm going to take out both of those things. I'm going to take out the 3, I'm going to take out the x. Then I work it backwards, right? I work it backwards, and I go, that would need to be an x squared. That would need to be a minus to get this back. And then that would have to be a 25. That guy is the difference of two squares. So I'm going to rewrite this as 3x. That's the same dude I already took outside. And then I'm going to say x plus 5, x minus 5. And I have factored it completely because there's no squared information left over here. Look, that's not squared, that's not squared. No squared stuff left over. Well, the bottom is the same question. No, it's not. This guy's got a 2. This guy only had a 1. So I can take out 3x squared in this one. Okay, big deal. I'm going to get an x minus 25. Oh, wait a minute. Do you see a squared here? No, you don't. I'm done. See, this one breaks up because there's a squared thing remaining. This thing stops. This guy's done. So both problems look similar, but they are definitely not the same answer. Okay. Now, we build a little at a time, little at a time. So these next problems are going to look similar to ones we did before. But the difference is this. In the problems we did previously, I never had you guys take out more than one x at a time. But see, look at this guy. He's the tiniest dude, but he's the greatest thing that they all have in common. So I'm going to take out x squared. Then I'm going to say we need 1, 2, 3 things to finish up this. X squared minus 5x minus 6. And I don't know about you, but I still see squared information remaining on the inside, which means I'm supposed to keep working. So I'm going to. I'm going to look at this and say, hey, x times x, that's how I do get this x squared. Oh, wait, I don't want to forget, this guy's out front. That's part of my answer. It ends with a minus 6. The only way to do that is a positive and a negative. And then don't blow it. Don't go, oh, 2 and 3. Because 2 and 2 take away, oh, yeah, that's not negative 5. Well, what am I going to do? Well, you got a different option. How about 1 times negative? There you go. Do you see that would be my final answer because I don't have anything else to break down. So when you guys get to this set of problems today, all you're going to be doing is saying, it's already in the right order. It goes third power, second power, first power, right? It's already in the right order. Is the highest powered thing negative in this case? No, that's just a positive 1 they didn't write in for me. Do they have anything in common? Sure they do. They have x in common, so I'm going to take that out. And then I'm going to work it backwards. I'm going to build this back. And I look inside and I say, I see a squared thing, so I'm supposed to keep working. And x times x, that would be x squared. Ends with a minus, got to be opposites. And it's not 2 times 2 that I want to use. That won't do it. It's 1 times 4. But I want it to be a positive 3. So I'm going to put the 4 here and the 1 there. Kaboom, I'm done. Don't make factoring be spooky when it doesn't have to be. And then you look at the next one and you go, but that looks pretty spooky. Nah, it's not that bad. Do you see the highest powered thing is negative, though? There's a negative out on the highest powered dude. So I'm taking that negative. It counts as being a GCF. I take it. And then I'm going to say, hey, 4, 3, and 2. 2 is the smallest power. Let's build it backwards. Negative x squared times x squared would be negative x to the 4th. Negative x squared times plus 7x would be that. And then plus 6 would finish this guy off. When you have to take a negative outside, you know what it does to everything? It changes everybody's sign. That's all it does. All of these were negative, but when I took them out, look, all of these dudes end up positive now. Negative is a sign-changing vehicle. Let's break it down. How do I know I have to break it down? How do I know that? I still see squared. So I go x and x. Last sign's plus. I need, ooh, I need 2 positives in this one. because a positive 1 and a positive 6, don't you see? That's going to give me back 7. There we go. That's some thing of beauty right there. So am I done? Yeah, because I don't have any squared stuff left over in those parentheses to mess with. We're almost through this lesson. But remember, you can rewatch it if you have to. You can pause it. You can ask me questions in the Zoom room if you get stuck on something. But we got one last set of problems to mess with. And this is when they throw everything at us. Everything they possibly can. But do keep in mind, it's already in the correct order. But this time, I threw a number in there. And sometimes you can take a number out. Sometimes you can take a letter out. Sometimes you can take one of each. And these are the one of eachers. If I take out 2x, let's build it backwards. I would need x squared right here. Because 2x times x squared is x third. Then I'd need a minus, and I think I need a 6 to get that 12 back, but I'd need an x. And then what's the last dude? I'd need positive, what, 8? Yeah, 8. And I go, I'm not done yet because there's a squared there, and I'm going to keep playing and say that's x and x. The last sign is positive, so it's either positive times a positive, but there's no way I'd get that there. So guess what? It's not 2 pluses. Instead, it's going to be 2 minuses. And do you guys see the combination I'm thinking of? It's not 1 times 8. That's not what I'm going to use. I'm going to use 2 and 4. But I don't want to get marked wrong, so I'm going to remember that I took this out to start the problem, and now I have the right answer. This is called factoring completely. Factoring completely. And I know I'm done now because that's a 1, that's a 1. If there's squared stuff remaining, I keep going. If not, I'm done. We have 2 more to try. Which one of these 2, is it going to be this guy here, the first one, or is it going to be this guy here, the second one? Which one of these 2 guys do I have to take a negative out of? First one or second one? Which one would I have to take the minus out of? This one. Which one of these 2 problems can I take a 4x squared out of? That would be this one. I'm going to do it. I'm going to take out a 4. I'm going to take out an x. I'm going to take out a squared. Why? Because 4 goes into all of these, and x squared is the baby in this group of guys. So I take out 4x squared. I go, I'm going to build you back. I would need an x squared here to get 4x squared times x squared. That would be this guy. Plus, I need a 6x to get back this guy. And then last but not least, it looks like I need a 9. And then we go, hey, let's break this guy up. How do I know it's going to break up? Because it's still got squared in it. So I'm going to go x and x. It ends with a plus, so it's got to be either 2 plus signs or 2 minus signs, but it's got to be 2 plus to make it say 6. And don't be thinking just 1 times 9, because guess what? 3 times 3 is the key to this one. That's our answer. That is our answer. If the same thing happens twice, it's okay. We're going to talk about that. Well, we did talk about it. It's called a double. It is. It's a double. No fancy talk. They just call it a double. So let's see. I want you guys to try this last one here. So pause it, give it a try, and then turn it back on and see if you and I match. Go ahead. Pause it. Did you pause it? Okay, pause it. All right, let's see if you got it right. Or did you not pause it? I don't know. I'm taking out a negative 2x third. That's what I'm taking out. Because I know the highest powered thing is negative, so it's got to come out. I am going to build this thing backwards. I'm going to put an x squared here, because that'll give me negative 2x to the fifth. I'm going to put a positive here because I need this to be a negative. So a negative times a positive will give me, and I need that to be a 3x. The last piece, I got to change its sign. if I do a negative times a negative, I'll get back a positive 20. So what was that? It looks like a 10. And I know that I'm not done yet because I see my buddy, the second power right there. So I'm going to say bustify x and x. It ends with a minus, so it's got to be positive times a negative to make a negative 10. And if you guessed 5 and 2, you guessed correctly. So my final answer looks like that. Okay, this is called factoring completely. You will see that factoring something completely is what we have to do in order to graph these things. And you might go, graph them? I have a graphing calculator. I know you do, but the graphing calculator also has a screen that's about this big. So when you graph something on that calculator like this, you're just going to see stuff go like, and then you're not going to be able to really see much of it because the calculator has that tiny little screen at the top. So we want to have an idea, what is this graph really doing? Well, after you know how to factor something completely, then you can learn how to sketch the graph, like a rough sketch. Not like a dead-on accurate sketch, but a rough sketch. That's what we're headed for. So this lesson right here, all these examples, you can review them if you need to, because guess what? You are going to see all of this come to life in this worksheet here. Factoring completely. I made up 18 questions. Some of them are just two terms. Like the first, 1, 2, there's two terms. 1, 2, there's two terms, etc. And then some are 1, 2, 3 terms. Some of them are 3 termers. I'm going to erase all that stuff. Oh my gosh, and I'm going to sneeze really loud. So here we go. This assignment, there's 12 problems I could fit on one page. Then there's 6 more on this next page. So 18 questions total. And here's the answer key. Okay. Whoops, answer key. So check your work. Make sure you're getting it right. And you'll notice every single problem has a GCF in it because I want you to practice the steps for factoring stuff completely. So once again, let's go up, pause it, take a picture of it so you can do them. There's 12. Pause it, take a picture of it. There's the other 6. Pause it, take a picture of it so you can check those answers. And don't forget, this is the key to doing factoring completely. You might want to take a picture of that and refer to it as we go through the practice. Okay, catch you later.